All right, so we've been multiplying and dividing and just simplifying rational expressions, and we're going to move in for the next probably 3 days into adding and subtracting. So you'll remember from your regular fraction work that when we add fractions, they have to have the same denominator. And if they do, right, when we add 1/3 to 1/3, we get 2/3, right? The denominator does not change. So for this first example, they already have a common denominator. The only thing we have to be really careful of when we do subtraction is that every term after the subtraction gets that negative. So it's really 9x minus 2x, and then 8 minus 3. So sometimes when we get to our final answer, we will need to simplify if possible. In this instance, we can't factor the numerator, we can't factor the denominator. We, of course, can't just jump in and cross out those x's. So this would be as good as it gets. So common denominator, again, on the next one, there is no reason to really factor the denominator yet, unless you want to. We really don't want to factor anything in the numerator because we're about to have to combine things together, right? We're trying to take two fractions, make them one fraction, and we're going to have some like terms that are going to combine. So if we've got things stuck in parentheses in their factored form, we're not going to be able to do that. So the first step is actually just going to be to combine all of these terms. So we've got a 2x to the second minus x to the second. So that takes care of those. Careful here, we've really got an x plus 2x because of that double negative. So x plus 2x is 3x. And then minus 10 because of that subtraction sign as well. So again, if at this point you want to factor your denominator, you can, or you can just wait till the next step. So from here we've got two trinomials. Of course, we can't just start canceling things out now. We need to put it into terms of multiplication in factored form. So I'm going to give you a second to think about what those would be, some of these more basic trinomials, and then I'll let you see if you're right. And then once we're in factored form, we can cancel anything that, right, is either the same or opposites. So this one is going to end at x plus 5 over x minus 6. So adding things that have like denominators, fairly straightforward. We combine the numerators and then it just becomes a simplification problem. If we have unlike denominators, things are going to get a little bit trickier. So we're actually going to do unlike denominators tomorrow. But these ones are kind of the in-between, the bridge, because they aren't the same, but they're not crazy different. A minus B and B minus A are opposites. And the good news about opposites is you can turn one into the other by multiplying by a -1, right? 3 times -1 becomes its opposite. -5 times -1 becomes its opposite. So what I'm going to do, and I am going to be picky when I look through your work for these, we have to show that the numerator and the denominator are getting multiplied by -1. If we just write times -1, right, like if you look down here at an example 4, if I just write times -1, that's actually not mathematically correct if then I multiply both by -1. So if you are multiplying both the numerator and denominator, which we are, we have to show it that way. So this is now going to become this second fraction. First one is going to stay the same. Whoops. Our numerator is now -4, and our denominator, either you can kind of distribute this and you'll see that it becomes -b plus a, or you can just know it's going to be the same as the other one. It's the opposite, a minus b. And then now that they have a common denominator, we can add them together. So I'm going to encourage you to actually try the next one. So to pause your video, do your work, and then check it. Oh, also, you are always welcome to multiply either fraction by the -1 over -1. If you did that, what's going to happen is you're going to get this as your answer, which is mathematically equivalent, right? If I were to take this and multiply by -1, I get -3. And if I take this and multiply by -1, I get the opposite. So most of the time I end up multiplying the right one just because that's where I have room on my paper, but it doesn't really matter. So I would pause and see what you get for this next one. And you should end up with 2. The more steps you show, the better in general, but if you can go, like if you want to go ahead and merge your fractions at this stage, that would be appropriate, as long as your reader can still tell why you've done what you've done. So adding with like denominators or almost like denominators is kind of day 1, but we're going to go ahead and look at, next time we're together, we are going to be adding fractions that don't have a common denominator. So step 1 is going to be finding that common denominator. So we are going to look at some where we figure out what would the like denominator be, but we're not going to actually go and solve any more addition problems. So numerically, your LCD is going to be just like it's always been. Thinking about what could I multiply each fraction by to get to this common denominator. So 3 and a 5, they're common, the least one, right? Of course, you could also make this a 30, a 5 times something, a 3 times, but the smallest one is 15. X to the 5th is the smallest as far as what they can both become. So, right, this one I could multiply by x to the 4th to get to that common denominator. And then our y to the 3rd, same concept. One of them already has y to the 3rd. This one only needs to multiply by y to create that common denominator. So this next one, when you have monomials, which we did in the first example, right, just one term as your denominator, I think it's a little more straightforward. When you have binomials or sometimes trinomials, you can look ahead. We want things to be in their factored form. It's easier to see what goes into them. And this one, of course, already is. Neither of those get more simplified than that. But z plus 1 and z minus 1 are just completely separate denominators. If you were to think about, like, if this were 7, one of the denominators would be 8 and one of them would be 6. They're not the same. They're not opposites. They may have something in common, but they don't, like for a specific z. But for the general z, they don't have anything in common. And so your LCD is actually going to have to just include both of those denominators, where the left fraction could multiply by the z minus 1s and the right fraction could multiply by the z plus 1s to create this common denominator of the two together. So if something is not in factored form, we want to do that first. So this is a spot I might encourage you to pause and practice your factoring of your denominators, and then unpause and see if you agree with me. All right. So again, these parentheses are all different, right? I can't just multiply like an m minus 2. I can't just be like, oh, if I add 7, you can't add things to numerators and denominators. We're always looking in terms of multiplication. So if I'm looking for the things they have in common, I notice there's an m minus 5 floating around. That needs to be a part of the common denominator. There's an m plus 5 floating around. There's a 2m plus 1 floating around. And there's an m minus 2. So all of those working together will create this least common denominator, where then our next step tomorrow would be, okay, this one needs to multiply by the m minus 2 and the 2m plus 1 to reach the common denominator. So the very last one, whoops, not a 2, 3. What I would recommend, So what I don't want you to do is have the LCD be all 4 of those parts. The 3, the 2 minus x, the x minus 2, the x plus 2. It would mathematically work. It would be very involved. But you've got 2 there that are opposites, and we can work with that. What I would encourage you to do, this expression is the same as this expression. So I'm getting a 3 times 2 is positive 6. Well, so is negative 3 times negative 2. 3 times negative x is negative 3x. Well, so is negative 3 times x. So I'm going to rewrite that a little bit better. So just by kind of changing the factor that I took out, it's a little bit easier to see that they do have something in common. So my least common denominator is going to include the thing they have in common, the part that one of them has that the other doesn't, another part that one of them has that the other doesn't, to think about building up to that least common denominator.